All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x minus 8 times x plus 3. For the math knowledge question, it says if p% of 75 is greater than 75, which one is true? Well, if we're going to take a percentage of a number and we end up with it bigger than what we started with, our percentage is going to have to be more than 100%. That's the only way that you're going to end up with a larger number than what you started with. Okay, so we are looking at lesson 11 today. We're going to be looking at circles, properties of circles, and then the quadratic formula. So hopefully after this lesson, you'll remember most of these terms about circles from geometry and how to use the quadratic formula that you should have covered in Algebra 2. So starting off with circle, it is the locus of all points in a plane that are equidistant from a point that's called the center of the circle. The radius is always going to be a line segment that connects a point that's somewhere on the circle to the center. So we go from the circle to the center, that's a radius. Or here's another radius. A chord is a line segment that connects any 2 points on a circle. So here's one chord, another chord could be here, another chord could be here. They just have to have endpoints that are on the circle. A diameter is a special type of chord, and it goes through the center of the circle. And the radius is always equal to half of the diameter, or the diameter is 2 of your radii. A secant is a line that intersects a circle at 2 points. So it's basically a chord that's been extended. Like this part here is the chord, and then you keep it going, and that becomes a secant. And then a tangent to a circle is a line that is in the same plane as the circle that intersects or touches a circle at only 1 point. So hopefully most of those concepts are review. None of those should be new. If y'all need to pause the video to go over them, y'all can though. So perimeter of your circle is called circumference. So you don't say, let's find the perimeter of the circle. You say, let's find the circumference. An arc, if you have a circle, you take 2 points that are on the circle, and then all of the points that are on the circle between them, this would be your arc from here over to here. So you can have a minor arc. That would be an arc that is less than 180 degrees, and you always name your minor arcs with 2 of your endpoints. So you only use 2 endpoints. Even if there was a point here in between, you wouldn't say B, D, C. Minor arcs only have 2 variables. For a major arc, you have to use 3 to name it, and they're always going to be greater than 180 degrees. So you start with one endpoint, and then you say another variable, and then the other endpoint. So B, A, C. If we had said just B, C, then we would assume that it's the shortest distance between them, which is not the major arc that we wanted. Semicircles are exactly half of your circumference. It's exactly 180 degrees. And if you have congruent circles, those are circles that have the same radii. Okay, so hopefully all of that is review from geometry. None of it's new. So now we're going to look at some properties of circles. One property is that the central angle is equal to the measure of the intercepted arc. So this arc right here is our intercepted arc, and this is our central angle. It's called a central angle because it starts at the center of the circle. And so if this is 44, then the arc is 44, and vice versa. If you have an inscribed angle, that's an angle that the vertex is on the circle. And so an inscribed angle is equal to half of the intercepted arc. So if this arc is 44, half of that is 22. So that's the inscribed angle here. Do you see how these all have the same endpoints here and here? They all have those same two endpoints. So they all have the same intercepted arc. So all three of these are going to be the same measure degree. And then if you have an inscribed angle that intercepts the diameter, then it has a measure of 90 degrees. The reason this here is 180 degrees, because it's the diameter, it's half of the circle, and then half of 180 is 90, which is a right angle. So anytime you have an angle that intercepts your diameter, that inscribed angle is going to equal 90 degrees. Okay, the next property, when you have an inscribed quadrilateral inside of a circle, the opposite angles are always going to add up to 180. So A and D here add up to 180, and B and C add up to 180. The product of the lengths of the segments of one chord are going to equal the product of the lengths of the segments of the other chord. So here, A times D is going to equal B times C. So one chord segments equal the other chord segments. And then the last one, two tangent segments that meet up at a point outside of the circle have the same length. So that whatever this is, this segment has to be the same thing. So again, hopefully most of those are reviewed from geometry. I know that's been a little bit, so that's why we kind of want to review them just in case you've forgotten them. So we're going to practice finding X and Y. I'm going to start off by using this 30-degree angle. It's an an inscribed angle, and its intercepted arc is right here. The other inscribed angle that has the same intercepted arc is right here. And so that means that this angle here has to equal this angle here. So 30 degrees has to equal y plus 20, which means that y is going to equal 10 degrees. Okay. Now I'm going to erase that so that I can use another color to help find x. This 46-degree inscribed angle has this intercepted arc, and this x plus 10 angle also has the same arc. So that means that these two have to be equal. So 46 has to equal x plus 10. So that means that x has to be 36 degrees. So that's how you can use one of your properties. We're going to look at this one. We're going to use the property that opposite angles in our quadrilateral have to add up to 180. So that means that 80 plus x has to equal 180. So x would be 100. That also means that 75 plus y has to equal 180. So y would have to equal 105. That's the first thing you would use. The next thing you would want to use is going to be dealing with your intercepted arcs. So we have this inscribed angle right here. And then it has an intercepted arc that is here. So this is half of this whole thing. So z plus 50 is going to be, when you take half of it, equal to 80. Or you can say z plus 50 has to equal 160. Because if this is 80, this whole part would be double. So double 80 is 160. And then if you solve for z, that would give you 110 degrees. So that's how you can use that property. This is the same concept as what we just finished on the last one. So we know that this angle here is 75. So its intercepted arc has to be twice that. So that means that x would have to equal 150. We also can use the same concept to find y. So we have this angle here, and its intercepted arc is right here. So if this is 35, you'd double it to get y. So y would equal 70 degrees. And then we can find this third angle here if you want, and then double it to get z. Or you can say, we know x plus y plus z has to equal 360, because that's the sum of your three arcs. And so x is 150, y is 70, and then we don't know z. But if you solve for z, you would get 140 for z. So either way would work. If you had solved it using triangles, this one would have been 70 degrees. And then double that to get the 140. Okay, we're going to look at another example. We want to find x. So on this one, we're going to do one secant. So the segments of that secant are going to be 15 and x plus 10. And then the other secant, or chord, these aren't secants, they're chords, would be 20 and x plus 5. So that's how you set up your equation. And then you just distribute and solve for your x. So 15x plus 150 equals 20x plus 100. And then if you subtract, you'll get 5x equals 50. So x would have to equal 10. So that would be your answer for x. We're going to look at another example. We have some tangent lines, and we want to find the value of x and y. If this segment here is 6, that means that this segment is also equal to 6. So x plus 4 has to equal 6, because they are both tangents and they intersect outside of our circle. So that means that x has to be equal to 2. And then also, we have this tangent and this one. So that means that x plus y has to equal 10. So if x is 2, then y would have to be 8. So that's how you can find x and y. We're going to go over how to derive the quadratic formula. We did this in Algebra 2, so you may vaguely remember this. Some of you may remember it very well. Some of you may not remember it because you refused to learn it in Algebra 2. You will have to do this on a test. You will have to derive the quadratic formula. So y'all can pause the video as you need to, but I'm going to go over what you're supposed to do. So the first thing you're going to do, you're going to take the c and move it to the right side. So we're going to have ax squared plus bx equals negative c. And when you're deriving this on your test, you have to make sure you show all of your work. If you don't show all of your work, then it's not going to get marked correct. So this first term would simplify to x squared plus bx over a, or if you want to write it as b over a x, and then equals negative ca. Then we're going to take this number right here, and we're going to multiply it by 1/2, so that's going to give us b over 2a, and then we're going to square it. And so that's what you would have. You're basically just going to be completing the square on this equation. So then if we add that to both sides of our equation, that's what you would get. From there, we're going to factor this side right here. And it'll factor as x plus b over 2a. And then on the right side, the common denominator is going to be a 4a squared. And so the b squared already has all of that in its denominator, so it doesn't get multiplied by anything. But the c doesn't have a 4, and it only has 1a, so we need to multiply the c by 4a. From here, you're going to take the square root of both sides of your equation. And so I get x plus b over 2a equals plus or minus. We can't simplify the square root of b squared minus 4ac, but we can take the square root of both 4 and a squared, and that would be 2a. And then from there, we can say x equals negative b over 2a, plus or minus the square root of b squared minus 4ac all over 2a. And then the last step, they both have the same denominator, so we can make it into one fraction. And that's your quadratic formula that you should know. If you don't know it, then you definitely want to learn it, because you're going to want to use it quite often throughout the year. So that's how you would derive it. So if y'all want, whenever you're practicing doing these at home, you're getting ready for your test, more than welcome to go back to this part of the video and watch it. Alright, so now we're going to actually use the quadratic formula. So for the first little bit, what I would recommend doing is writing down the quadratic formula on your test, so that if you've messed up in your memorization, then I can say, hey, this part of your equation is not correct. Or I can say, yep, that's the right equation, you just didn't simplify it correctly, or plug it in correctly. So you always want it to be equal to 0 whenever you go to use the quadratic formula. So the coefficient in front of the x squared is going to be your a, the one in front of the x is your b, and then your constant is your c. So negative b would become a positive 2, plus or minus negative 2 squared minus 4a, and then c is 5, all over 2a. So we would have 2 plus or minus the square root. Negative 2 squared is 4, and then 4 times 3 times 5 is 60, all over 6. So 4 minus 60 we can simplify, and that would be negative 56. So 56 does factor as 8 and 7, and then 8 would be 2 and 4, and 2 and 2. So the square root of 56, we have a pair of 2's we can pull out. So that would be 2 and then square root of 14 left over. And when we have a negative in a radical, we pull it out and make it an I. Then all over 6. And then the last thing we're going to do, 2 over 6 reduces to 1/3, plus or minus 2 over 6 again reduces to 1/3. So we don't have to put the 1 in front of the radical, although if you do, it's not wrong. And so that would be your answer. And we put it into two separate fractions because when we have a complex number, we want a plus bi. So that's how you can use the quadratic formula. Even if it factors, you can use the quadratic formula. You would just end up with something where x equals 2 and negative 3 or whatever. If your radical, let's say I had 1 plus or minus the square root of 100 over 2, we can simplify that to be 10. You wouldn't want to leave your answer here. 1 plus 10 is 11, so we would have 11 over 2. And then 1 minus 10 is negative 9, and we would have negative 9 over 2. So you would want to make sure to simplify completely and not just leave it here. This is not right. You want to put it in your final answer. Okay, so that's how you can use the quadratic formula. Your homework tonight, you do get to omit number 19, 20, 21, and 25. So you only have 26 problems. Make sure y'all do those tonight so we can go over any questions you have tomorrow.